We are going to do the experiment number 1, the conductance of solution and determination of dissociation constant. In this experiment, you are going to find out the dissociation constant of acetic acid, measuring the conductivity of some solutions. In this experiment, you may need different equipments. Here you can see the Winston bridge, multimeter, and connecting wires, and conductivity cell, and different solutions, and the variable resistors. Now I am going to connect the Winston bridge to the multimeter, conductivity cell, and the variable resistor. First I will connect the Winston bridge to the multimeter. For that you need the connecting wires. First connect the wire for this pin. And connect the two wires like this. Now I am going to connect the Winston bridge to the conductivity cell. Finally, I am going to connect the Winston bridge to the variable resistor. Variable resistor has 3 pins and the middle one is connected to the ground. Therefore, the connecting wires should be connected to the first pin and the third pin. Now we have finished the connections. Before taking the conductivity measurement, I am going to clean the conductivity cell. For that you can use the distilled water and you can use the sandpapers to clean the surface of the cell. First I use some distilled water. Then I use some sandpaper to clean the surface of the conductivity cell. Then you can use again some distilled water to remove the impurities in the electrochemical cell. When you are doing your experiment, wash the conductivity cell several times with distilled water before each measurement. After you clean the conductivity cell, now we are going to determine the cell constant of the conductivity cell. For that you have to measure the conductivity of the known concentration of KCl solution. For that we will use the 0.02 m KCl solution. Now I am going to measure the conductivity of the 0.02 m KCl solution. First, make sure the Winston bridge should be connected to the electricity. And in the multimeter, you have to turn on the position to the ACV 200. Then I will take the 0.2 m KCl solution and put this solution to the beaker. Then take the conductivity cell and dip it in the solution. Make sure you should dip the conductivity cell near to this tip and don't put too much solution to the beaker. Then you can see the potential difference show as the 0.8. Then you can change the variable resistance, and you can see when I change the variable resistance, the potential difference value show the potential value is changing, and we should adjust the variable resistance until the potential difference get 0. Now you can see the value is come to the 0. Now I am going to check the resistance value of the variable resistor. First, remove the conductivity cell. Then I am going to connect the 2 pins for the variable resistor to the multimeter. First, remove these 2 pins and connect the variable resistor to the multimeter. Then you can measure the resistance value of the variable resistor. You can see now the resistance value is 600 ohms. Using the resistance values of the KCl solution, you can calculate the cell constant. As the next step, you have to prepare the different solutions to take the dissociation constant of the acetic acid. For that, you have to prepare the different concentration of HCl, sodium chloride, sodium acetate, and acetic acid solution. In this video, I will take the HCl solutions as the example. Make sure before every experiment you have to clean the conductivity cell. Now I am going to measure the resistance of the 0.1 mHCl solution. The method is same as before. Add some HCl solution to the beaker. Put the conductivity cell and check the potential difference and change the resistance until it come to the 0. If the resistance cannot come to go to the 0, you need to change it. Now I am using the 2k ohms variable resistance, but this value cannot go to the 0. Therefore, I am going to change it to the 10k ohms variable resistance. Now I have changed the variable resistor, and we will look back again to get the potential difference value to the 0. Now you can see the value arrives to the 0. Now I am going to measure the resistance value. For that, first remove the 2 pins and also remove the conductivity cell, and I am going to connect these 2 pins to the multimeter. Let's check the resistance value. See the value as the 102 ohms. Let's check the 0.05 mHCl solution resistor. First, I take the 0.05 mHCl solution and put into the beaker. Then I place the conductivity cell. Make sure to clean it before you use again. Now I am going to change the variable resistor to get the value as 0. Okay, now it's get 0, and now I am going to check the resistance value. Yeah, now you can see the resistance value as 168 ohms. Now you can see compared to the 0.1 m HCl solution, the resistance value get increased. The reason is we use the low concentration of HCl solution, 0.05. When the concentration get lower, the resistance value should be get higher. In your experiment, you have to measure the resistance of 3 other solutions: sodium chloride, sodium acetate, and acetic acid, to find out the dissociation constant of the acetic acid.